Well, good morning, everybody. Great to see everybody. Today, we're going to spend a little bit of time talking about automated feeding and how automated feeding can help manufacturers overcome some of the really critical issues that are affecting them with regards to labour shortages. With me today is my colleague George Brown, who I'm not going to lie is a bit of an expert in all things robotics, and particularly with collaborative and autonomous technologies. George is really going to shed a lot of light today on some of the technical aspects of feeding in many different manufacturing contexts. So, welcome, George. Great to see you.
Yeah, glad to be a part of it.
So today, what we're going to talk about is we're going to go over a little bit of the backdrop in terms of what's going on in the sector, the economic impact of that on both manufacturers and the overall UK competitive landscape, and then we'll really dive into some of the nitty-gritty of how manufacturers can assess the need for automated feeding technologies, how they can deploy them, and the benefits they can expect to reap from them. We've got a couple of really nice case studies that we're going to share with you this morning, and some videos of what this might look like in practice. So, to kick us off, really, I think we're all aware of the challenges that are facing the UK manufacturing sector, particularly in the context of vacancies. It's something that has been going on for some time now, probably since the pandemic for sure. And whilst we're not at those insane heights of vacancy levels that we saw in sort of early 2022, and I think doing research for this, we saw a staggering 96,000 vacancies in manufacturing in the UK. We're certainly not at those levels now, and the economy has really driven that down somewhat, but we are still at a good 20% higher than we were before the COVID pandemic. So, there are still 61,000 vacancies in UK manufacturing. That's the Office for National Statistics data as of the end of August. So, we still are in a little bit of a pickle as a sector. So, it's not just that vacancy data that is causing us a problem. There's also some significant challenges with the skills that are needed, both for today's manufacturing environment, but furthermore for tomorrow as well. So, some of those skills include robotics and automation. There is data processing, the ability to actually take production data and turn that into actionable insights, are skills that we are in desperate need of being able to develop in the sector. And these are having a quite clearly demonstrable effect on productivity. I mean, some of the anecdotes that I've seen in recent months of visiting a number of different production facilities is still in 2024. Some of the most basic tasks on a shop floor are still being done by humans. So things like inserting raw ingredients into food processing, inserting packaging materials manually into lines, for example, trays prior to filling. There are still many examples of humans manually fulfilling these tasks. So these are really easy wins for manufacturers to be able to automate. And what we're going to talk about today is how we can do that. The impact of that on the UK as well as a competitive economy are starting to become really staggering. It's very expensive now to produce things in the UK, and a large part of that is that we are, comparatively to other economies, still very reliant on human labour to fulfil simple tasks. So with that in mind, I think it really does make sense for us to start to look at automated feeding as a viable solution, particularly for robotic adoption. The UK, I think, is still the 7th or 8th biggest economy in the world, but we are languishing still down in 26th-ish in terms of robotic adoption. So for me, that tells its own story. But I'm going to start, asking George a few questions now. So, when we talk about automated feeding, George, explain what that means.
Yeah, so exactly as you're saying, there's obviously a lot of manual labour that's being done in almost every manufacturing site. It's probably like the sin of a manufacturing site almost, where we're having labour to move a product from probably essentially a bulk storage onto the machine itself. So this can be a very mundane, repetitive job, which includes its own challenges. But it's utilizing the technology so we can physically get an object of one kind, which is sitting by a machine, near a machine, into it. So quite simple of just getting it from that stage of having some use to make the machine useful. Otherwise, it just sits at a standstill. But it's replacing that effort using the right technology and doing so. And robotics is kind of one of the easier kind of ways to get a win out of that without deploying necessarily a large in-feed machine in itself. So looking at collaborative robot technology, which we'll see a great case study later of how we can do this quite flexibly and without having a massive investment as well in the first place.
No, fantastic. And you mentioned some of those challenges there, and aside from the obvious challenge of capacity when we've got high numbers of vacancies in manufacturing, what are some of those other challenges that are inherent when we are relying on people to fulfill these tasks?
Absolutely, I think one challenge in particular, and this I'm sure will ring true with people actually physically doing this job at the moment, is the amount of stress that this puts on physically as a human doing this type of operation. RSI type injuries, like the ergonomic injuries. If you're doing an 8-hour shift of moving an object from left to right, we've all been working in the garden or whatever. You do that for 2 hours and you complain about it for the rest of the day. Imagine doing that all day, moving trays from a pallet to a machine. Is a very obvious kind of challenge for the operators themselves. It doesn't make it an attractive job to do as well in the first place. So it kind of loops back round to, we then have the labour challenge again, because it's an unattractive job to fulfil. That's a major challenge in feeding as a whole, I think, across the industry. And sometimes I think the perceived complexity and scalability of deploying feeding solutions can also be a challenge when you're not automating. How do you keep up with that production? Are you limited to the amount of hours that you can operate? If you can only have operators during a 8 till 4 o'clock shift, what about the rest of the hours of the day? You want to utilize that time. That machine can still work for 24/7. So if we can't get people there, how do we make it smarter so we can utilize more of the day?
Absolutely, and those are very, very real issues. I think the other one that springs to mind for me is those potential errors that humans can make as well. It could be something like feeding the wrong part into the process, or putting it in the wrong place. What sort of impact do these challenges end up having on production?
Exactly as you say there. If we're thinking from a quality point of view, or the quality of input, the work that we're doing, human error, simply putting a tray in back to front, that could have a machine down for 20 minutes before we first get in. Have we got the right method of indicating an operator or a maintenance engineer of an issue? So we've got that delay. Then we've got the actual recognition of the fault, and then we've got the additional delay of repairing the fault that happens because of an issue like that. Whereas if we deploy a technology which can ensure that everything's done the right way first time, and if there is something that goes wrong, maybe the wrong product's fed and the full deployment isn't done, where we use vision to identify things, at least we have like traceability in the background as well within there. So yes, this can help from reducing downtime in the first place, and reducing even quality issues as well.
No, fantastic. So when we're looking at actually, let's position ourselves as a manufacturer, and we're starting to assess whether investing in some form of automated solution to support these feeding activities, what potential opportunities is that going to bring me as a manufacturer in the future?
Yeah, so it's going to open up scalability. It's going to make your reputation as a business as well. Is that you're being an innovative manufacturer. You're looking to it's going to be more attractive to people working there, because they're not going to be doing lots of mundane tasks. They're going to thinking, right, I'm going to be utilized here. I'm going to be working with the latest technology by me. I'm going to be able to do a high level of work in my place and add the right value here as well. But it opens up so many avenues for I'm sure we've all heard of utilizing data now as well. We want to as our kind of end users or consumers as well are requesting more specialities in kind of what they're receiving, or a bit more uniqueness, that allows us to be more flexible from the manufacturing line and actually provide more information going forward and have that continuous improvement rather than everything being very manual and a lot of the data in the kind of detail gets lost during that, just through human nature as well, because we're not able to log every little bit of detail on every line, because it's impossible at the end of the day unless we automate things.
Absolutely, and I guess there's probably quite significant improvements in both productivity and efficiency that can be reaped there. What could the impact of this be on the overall OEE of a site?
Oh, 100%. Well, like I said earlier, you could operate 24/7 for a starter. So we're operating throughout the full day. We're getting full utilization out of the machine. So your return on investment actually goes far quicker than it traditionally would by having the limitation of an operator where you're limited to a third of that time. So straight away we can cut time down massively there. But cycle rate can be improved if you're having to we'll see a great case study later again, but where you might have an operator going between 3 or 4 machines, you've got that time in between where they can't keep up with the machines that they're not physically at. You can only be at one place at a time, whereas if we're automating things are working in parallel, cycle rate can go up exponentially.
Fantastic. Yeah, totally agree. And I think also, when you look at that added consistency and accuracy that automated systems bring into that process, as you said earlier on, there are a lot of catastrophic errors that can cost an awful lot of money when they're taking the machine down that are often totally eliminated. So, there's a really, really big win there as well.
It's the hidden ones, isn't it? What you would never think of, that people do things and they probably have a reason as to why they do it that way. But if you have it all structured, everything happens. And fortunately, well, unless we're putting machine learning and AI into things, machines will do the same thing at the same time today as it will in 5-10 years time as well. So
absolutely. And what about the impact on culture? Because a lot of people that are working on production lines are often a little bit wary of automated systems because they see it as a threat to job security and that sort of thing. But of course, we're very much of the mindset that this technology is not here to take jobs away. It's here to create new, more exciting, more value-added jobs. Did you agree with that, George?
Absolutely. And what from experience working with customers on site is the best way to kind of tackle that perceived negativity to deploying technology alongside with operators is to embrace them and bring them into the story of it as well, because then they understand exactly why it's coming in there. It actually supports them and they can understand how it supports them, and they can also add input as to I do this in a certain particular way because of X, Y, and Z. Whereas if they're not consulted, things like that get missed, and then the production doesn't work well, the project's maybe not a success or as successful as it should be, and then that then kind of further impacts on the operator again because they're having to pick up the pieces where the machine's not doing it. So it's kind of got to be in conjunction with the two. But as you rightly say, when they are involved as well, is they gain the development and experience of this, and then they might then recognise as a part of their career future is that they're working with the technology and helping to deploy it further on. So there's different development opportunities for them personally as well. There'll always be some stigma towards it about taking jobs, absolutely. But it's having them involved with this and training them up to be able to use it efficiently. And ultimately, it's going to reduce the workload that they're going to have to be kind of kept up with day to day. I know a lot of operators are flat out all day, and it's physically very demanding again. So it's there to help them alongside, and as a business also kind of become more profitable and increase their kind of OEE, as you were saying. So the business grows and they can grow along with the business as well.
Absolutely. So we've got a case study we wanted to share with everybody here today. This is a deployment of one of our automated feeding systems at a company of ours over in Europe. So I'm going to play a video there, and then George and I are just going to quickly unpack that afterwards.
My name is Lars Nielsen. I'm the factory manager, COO here at Fischer Gears. Fischer Gears is a third generation gear manufacturer placed here in Randers, Denmark. We are an old company with a lot of different customers, but all of them are international players. Rolls-Royce, MAN for ship engines to mining. What we want now with these robots is also to be able to produce high precision gears in bigger volume. Smaller parts can be handled by robots. They can take the part, put the part in the machine, and close the doors and take the part out and put it on the pallet. We chose OMRON because the vision part was included in the robots. The robots are very flexible due to the landmark. When moved to the machine from another machine, when they look at the landmark, they almost know where it is. Then you only have to choose the program that you want to run. And also the safety of the scanner that could be put on the robots. They're easier to have in an open factory environment, not to hit anyone or not hurting anyone. The industry needs robots to expand, also to be compatible price-wise, also for the employees not to do the same movement all day long and get worn down. Of course, there's a cost benefit that we can produce also when the employees are going home and the factory are closed. The robots can still produce. We had Nord Electro as our service partner, who's doing all the implementing of the robots. So we thought that OMRON was the best robot for us.
Many of which we've already talked about in terms of those that increased throughput, scalability, and ultimately cost reduction that we can realise from these kind of solutions. But one thing that really jumped out for me there, George, was that that ability to actually redeploy some of these systems from one process to another. Tell me a bit more about that.
Yeah, this is one of the fantastic things about deploying collaborative robotics is the flexibility that it offers. So in this case study in particular, there are 2 collaborative robots which are being used within the facility, shared between 4 CNC machines. And both the collaborative robots are installed on what we call a mobile workstation. So what this allows is the robot to be deployed at one of the CNC machines for however long that's needed, or however much product there is needed, I suppose, to process, which is where the workstation is on physical wheels. So someone can just move the robot into the area, and then the robot can operate within there. And we can go into how that works in a bit. But once that kind of process has been completed, because it's a mobile workstation, is that robot can then be utilized in the next CNC machine, which is waiting for product to be done, to be processed again, which if you had the traditional like fixed robotic technology, you would be having full guarded machinery, which would be one machine until it's decommissioned, essentially. You're not going to be moving all of that. So this allows that the robot can be utilized across several machines, affecting the ROI on the project as well. So we're not having one asset used for one process. It's shared across multiple on there. So what's really great on top of this as well, going into a little bit more of the kind of technical solution here, forgive me, I'm a technical guy, so this is what I do. So what we've got on the collaborative robots there is a vision camera, which is used to physically locate the parts which are going to be processed and placed within the CNC machine. But there's also a really neat and something which demonstrates to everyone who will listen is this landmark feature as well. So where I mentioned that the robot is transported from machine to machine, traditionally with robotic systems is that you'd have to accurately mount it in a location so that all the positions are right, almost to like a datum point. But what's really special with this is with the camera, we can use this landmark feature, which identifies a very specific object, which we teach, and then it uses that as its datum point. So this is physically stuck to the machine or somewhere within that environment. So it uses that to locate everything else from its points. So when we're actually placing the robot in this area, it doesn't have to be within the millimeters. It has to just be within the right kind of vicinity, enough so it's got enough reach to process everything. So it makes it very flexible to be deployed across several machines without really having to take much time. So really, it's just a cable connection really when you get there to give it power. So we're not spending half an hour to lock it into place specifically. We're just getting it to that area and letting it run. Now, what would be really ideal in the future as well is deploying that with mobile robotics on top as well. So then we don't even have to have an operator in the first place to move the robot there. It all does it autonomously. So that could be like the next stage of where this could progress as well.
Yeah, really exciting technology there, George. And that idea of robotics that are mobile on the shop floor, I think really does unlock really exciting new possibilities. You've mentioned a lot in there about flexibility, and I think that flexibility is really, really a key driver of that return on investment that you mentioned. And I think being able to flex that production capacity in different areas of the shop floor, I think not only gives a very, very clear and tangible ROI, but it brings some hidden elements of that as well, doesn't it?
Absolutely, yeah. If you're looking at a project to deploy a robot on, and it's kind of, we'll maybe get our investment in 2 years, but there's actually another process, and it starts to build a bit more of a story of robotics can be used in so many different areas and so many different use cases, and it gives you more reasons rather than just to tackle one issue to deploy that. Obviously, we've got the flexibility as well with the vision. Is you start to also look at we've got the process itself, but can we improve the process as well? If we're using the vision, do we do the quality inspection as part of this as well? When we start to build this traceability log, if there's barcodes, laser engravements on any of the products as well, do we start adding that, and then that adds value to the product even further that we can provide to the consumer or end user as well. So we can start to realize, yes, we're replacing this set of work, but can we add more value to it as well in the first place?
Yeah, absolutely. So if we was to start looking at how do we deploy these kind of solutions, if I'm a manufacturer, how do I start to look at whether a task is feasible for this sort of solution?
Yeah. I always say, and this might be kind of saying the obvious, but with like robotic projects, don't go straight into the deep end. Kind of let's work at what's we think is the most kind of tangible, what's not going to be impossible to do to go there. But the key thing really is to have like that open discussion really with whether it's the manufacturer or whether it's like a machine builder that you're aware of, because it's not always straightforward as to what a robotic project is, either a dead easy one or complex. It's having that conversation with people which do understand the technology and know where it can be deployed, because moving a robot from A to B might seem easy enough, but what about the manipulation of the product as well? Is it something which needs real dexterity in handling the product? Is it delicate or something like that? But having that conversation with people just opens up the kind of possibilities and feasibilities. Kind of working with OMRON, we can do like proof of concept studies as well. We can do a great initiative, what we call Gemba walks as well, is to walk the line with yourselves to understand kind of what pain points there are within kind of the manufacturing line, what issues are there, what challenges are there, and we can help as well to say, well, this type of technology is perfect for resolving this type of issue, and then build the story that way and identify what the best route is for success ultimately.
Yeah, and you know, as we know, most manufacturers that will want to look at this kind of thing will obviously already have a lot of machinery on site as well. How easily does this kind of technology integrate with existing machinery?
Yeah, so like technology we've shown here today is all very kind of open. It's kind of almost it's very accessible as a new user as well, which is important with this. I think a lot of people see collaborative robots as, I think in the name of it, it's obviously safety driven, which is absolutely correct, and we can go into. But we also want to think that collaborative will also mean that it's accessible and it's workable with other people and machines as well. So operates on very kind of open type protocols, but also very down to the very simple. We're talking about CNC machines. Many of them are 20, 30 years old, and it operates very much on just very digital signals here and there, which absolutely we can integrate with that, or we can integrate it with machine controllers. Really, it's very open to whatever's needed at all.
Fantastic, and I guess that that flexibility that we spoke about earlier on brings quite an easy scalability element to this, right?
Of course, yeah. Once you get started, it's working out what the next step is and bringing in this automation. Don't think it has to just stop at the robot. You've got the controllers which add on to it, and then sky's your limit, really, essentially. If you want to deploy one to start off with, it doesn't have to be the full solution to start off with. It might be that you've got 3 operators doing feeding in one area, but perhaps you have 1 operator and 1 collaborative robot to start off with. And we start off with that and make sure the technology fits well and it operates well. And then maybe the second robot comes in and there's no operators going forward, so they're deployed elsewhere. So the scalability then also grows, expands further.
Absolutely, and I think you mentioned earlier on about that accessibility of the technology in the backdrop of the clear skills issues that we alluded to at the beginning of the webinar. I think that's a really important point to focus on. Really, is that fairly low complexity in terms of programming collaborative robots in particular really does make that a lot simpler and less risky for people, doesn't it?
Indeed, yeah. So just as an example that I say a lot is that traditional robotic systems, you could do a month's training to learn 80% of the full functionality of a traditional fixed robot. If you compare it to a collaborative robot, 4 days, maybe 3 days to learn 80%, maybe even less. It depends how familiar you are to robotics, but we do a lot of training in our Milton Keynes office with on a basic course, which actually covers about 65% of functionality of a robot. And we have ranges for people that have never touched a robot at all, people which are maintenance engineers, people which are full programmers, robotic programmers, control system programmers. Very accessible for all. It's very graphical as well, so you don't have to be a traditional kind of high-level programmer. It's tailored to people which are used to the operating kind of manufacturing sites. It's all very structured in that way, so it's excellent to pick up, even if you're not familiar with the software, to kind of visualize what's going on. You can almost watch some YouTube videos and get the robot going to some extent. So yeah, it's miles different to what we traditionally see in robotics.
Yeah, I think even so it must be pretty straightforward if that's the case. So talk to me about safety concerns, George. Obviously robots can be perceived as quite dangerous, but with collaborative robots in particular, safety is clearly a key consideration. But tell me a bit more about that.
Of course. So yeah, with collaborative robots, we traditionally see it without guarding around the robot, which is one of the kind of great cases of using a collaborative robot, but we've got to do it in the right way of doing so. So like in this case study, in the video that we would have seen, there was a safety scanner which was being used. What that safety scanner will do is when it detects that there's a person within the environment near the robot, that will then send the robot into what we call collaborative mode, or collaborative speed mode, I should say, which lowers the robot's torque levels down, the speed levels down as well, to a level which is deemed safe for a human to be in the same vicinity of the robot. So if it was to come into contact with the robot, it's that it wouldn't cause any harm as such. So there is a technical specification, 15066, which is released in the UK, which defines kind of if an operator is in the same area as a collaborative robot, at what speeds it should operate at to mitigate any hazards or high-level hazards at all. So the robots will completely comply with that. And it's still necessary to perform a risk assessment, like with any machine. We've got to remember at the end of the day, regardless, even if it's a collaborative robot, it's still a machine within there. But the safety functions that are available are far more vast than traditional robotic machinery, is that it does allow it to be more flexible and more approachable from a safety point of view without having fixed guards around it all the time. So deploying the right safety devices around it as well makes it flexible. And that's why it's specifically in this case where the robot can be moved from cell to cell, that it doesn't have to have the fixed guarding around it. We can use the safety technology around it to make it a safe deployment regardless.
Yeah, fantastic. And then also, another question we get asked a lot is how easy are these things to maintain? If they break down, for example, how quickly can I identify the problem and get it back up and running again?
Yeah. Again, so traditional robotics, there's a lot of moving parts within those, lots of belts and whistles and all sorts going on within those. So they can have traditionally more maintenance routines needed. But with the collaborative robots, it's we suggest like preventative maintenance, which is performed yearly or every 6 months within there, which generally a lot of it is general maintenance of cleaning kind of the robot arms, making sure that kind of dust filters are cleared just for the health of, like you would with any machine. But in honesty, with the collaborative robots, there's far less kind of parts which need to be routinely managed. Is that it becomes this maintenance is more of inspection and cleaning, with the preventative maintenance where we can have a robot service engineer come and do some internal works within there. There's not actually too much to maintain on the robotics. And if we need to do a repair, then we can have the spare parts either on site, or we can arrange for a quick repair with one of our service engineers locally as well.
That sounds very, very reassuring. So finally, George, to wrap up this part of the webinar, I think what are your main tips for people that are looking at trying to implement an automated feeding system?
Yeah, main tips really is speak with like manufacturers like ourselves, OMRON. Obviously, we're always here to help support find the right applications. There's nothing wrong than investing and then working halfway down the line that perhaps this wasn't the best application to start with. So communicate is the main thing with us, and we can help to identify what's right to move down. But also think about scalability of this. So it doesn't always have to be the full solution to start off with. Where's a good start for deploying the technology into kind of automated feeding areas? Is there ways that we can do one robot between 2 or 3 machines as well, like we're seeing with here? Definitely kind of think about what other areas. Don't always just think that a robot has to be used for one task. We can deploy it across multiple, and that may help with the challenge of the ROI in some cases. If we can think of multiple uses for a single asset, it makes it far easier to justify the investment. And I think key one is engage with your operators as well as how the technology could be used, understanding the true operation of what they are doing, what complexities are there, and give them training, get them involved with the project, and help them to develop through using technology as well.
Yeah, brilliant. Well, let's take we've seen one example of what this might look like in real life. Let's take a quick look at another. So another really nice example in a completely different industry of where we can really take out some of those manual tasks that are often fraught with inefficiencies as we've seen. So looking forward, I think we've got to really start to take note of these things. That technology is evolving so quickly. We have clear issues that need to be addressed within our local sector, and I think these kind of solutions really can play a pivotal role in helping UK manufacturing overcome some of those difficulties. I think as we start to see technology evolve, George mentioned earlier on about having things like cobots mounted on top of mobile robots, which brings another additional layer of flexibility into many different processes. But there are also ways of taking really simple wins with simple automation, such as denesting and other such technologies. So we really are starting to see some significant innovation coming in this space, where manufacturers see this as an easy win and are really starting to push the boundaries of how they can get key consumables and parts into processes quicker, faster, more accurately, ultimately improving productivity. So as we wrap up this session, we've kind of looked at the overall landscape and why there is a need to start looking at trying to automate many processes in manufacturing, one of which is obviously automated feeding. We've looked at some of the potential wins for manufacturers. George has given us some fantastic insights there into how we can go about deploying these scenarios and some of the pitfalls that we need to think about and consider. And we've seen some real examples of what it might look like in real life. So hopefully that's given all of you some inspiration. Our call to action here is really to discuss this within your own organizations. Try to identify ways that you can deploy these technologies and really unlock some productivity wins. And most importantly, come and talk to us about it, because we're here to help, and we believe we can really work closely with you to unlock new value in your manufacturing operations. So thank you, George.
No problem. Thanks for
thank you. Thank you to everyone in the audience, and we wish you a good day.
Thank you.